Hello everyone. So in this video, we're going to continue our study of regular expressions, and specifically, we're going to continue our study of characterizing what languages and what strings are denoted by a particular regular expression. And so in this exercise, we're doing this in a slightly original way, if I do say so myself. And it's to characterize all of the strings of length 3 or less that are in the language denoted by R. Okay, but really to do this really precisely, what I'm going to do is I'm going to first determine what the language denoted by R is, and then gather what strings of like 3 or less are in there. Okay, so what I'm going to do then is I'm going to start with applying the language denotion operator onto the regular expression R. So L of R is L of the regular expression 0 plus 0, 1, and 1 plus 1, 1 star. Okay, so let's see. So now what we're going to do is, well, we have a concatenation here. So we're going to apply the rule for applying L to the concatenation of two regular expressions, which is just to take the concatenation of the languages denoted by each of those regular expressions. So this is what we get. And then here we're going to apply the star operator to the language denoted by 1 plus 1, 1. And here, let's just keep this like this for now, because what we're going to do immediately after is we're going to apply the plus to union conversion, right? So I'm going to skip the concatenation of primitive letters to a larger string, and I'm just going to write that this is equal to the language 0, 0, 1, and then concat 1, 1, 1 star. Okay, and so actually what you can immediately notice by this, okay, expression is that, well, if you have 1 and 1, 1, and you're applying the star operator, well, this is actually going to be equivalent to having 1 star. Okay, why? Because what the star operator tells you is that any string W that can be formed by W1, W2, Wn, where W1 is in 1, 1, 1, W2 is in 1, 1, 1, and so on. Any string that can be created this way is in 1, 1, 1 star. Okay, but if I ever at any point use 1, 1 to create this new string, then I can just replace that by using this first symbol 1 twice. Okay, so in fact, this additional 1, 1 doesn't actually make my language contain any more strings than it already does. So I can actually simplify this to equal 0, 0, 1, concat 1 star. And so what's interesting is that you can also then immediately notice that if 1 plus 1, 1 star denotes a language, L1, right, then 1 star denotes exactly the same language, L1, okay? And so this won't always be true in general, of course not, because we have different regular expressions that denote different languages, but what you can note here is that there's two regular expressions that denote the same language, and actually by this same logic, there's an infinite number of regular expressions that denote the language L1, because you could have something like 1, 1, 1, 1, 1, 1 star, and that would denote this, right? Because these two extra regular expressions aren't actually doing anything, and so on, right? So you can have any number of concatenations of ones, and that wouldn't really give you anything else as long as you have this singleton one. Okay, that was kind of an aside, right? An aside just to tell you that there is an infinite number of regular expressions that denote a single language L. Okay. Okay, and so now if we get back to the initial question, which was find strings of length 3 or less, well, if we expand this just a tiny bit, we get the empty string 1, 1, 1, and we don't actually have to go further because if we need strings of length 3 or less, and we're concatenating a non-empty string with some string in here, because this string here is going to be non-empty, if we have anything that's length greater or equal to 3, the resulting concatenated string will be of length greater or equal to 4. Okay, so we can actually stop here. And we see that 0 concatenates with the empty string 1 and 1, 1. So we get 0, 0, 1, and 0, 1, 1. And 0, 1 concatenates with the empty string and with 1. And then, like I just said, we get a string of length 4 or more, and then there aren't any other strings which are smaller. So 0, 1 gets repeated, and so does 0, 1, 1. So, in fact, the strings of length 3 or less that are in L of R are only 0, 0, 1, and 0, 1, 1. Okay? And so this was another example of creating or of identifying the language denoted by a regular expression, and in this case, doing something a bit more interesting with that language.